This is the P1B1 Sky Voyager. It is a rubber-powered free flight model, and I've converted it to radio control. I never thought I would see the day, but it's here. Technology has taken us to this point. A rubber-powered free flight model, 2-channel radio control, all up weight, 43 grams. If you prefer English versus metric measurements, it's 1.5 ounces. I purchased the model from J&H Aerospace. It's a 25.5-inch wingspan, foam wing and tail feathers, plastic tube fuselage with a carbon fiber tail boom. Has a folding prop with a reverse Montreal stop in it. Works very well. And the model, the free flight, rubber powered free flight model, only costs $28. Initially, I built this as a rubber powered free flight model, and then I installed the radio. For the radio, I have what's called a micro brick. So that's receiver, 2 linear servos, and a 70 milliamp hour lithium ion battery. I've installed carbon fiber control rods, and I've cut out the control surfaces and made little lightweight balsa wood control horns. So did that, and then I took it outside for a test glide. Let's check the glide with everything at neutral, like I would fly it as a true rubber powered free flight model. Breezy out here today, behind the house. Just have to do the best we can. Wait for a moment here. See if I can't get a little glide action in here. Okay, I think I'm going to do that one more time. Maybe at a slightly different angle, maybe across the yard right here. See if I can't get a little better feel on the glide. I'm behind the house, got a southwest wind. Just trying to find a spot where I can check this glide. Yeah, I got a little more dead air right here. Not much. Do have the radio. And again, I took over with the radio at the end there, kept it pointed into the wind. That was less than ideal conditions to be checking the glide, but I found out what I was mostly interested in, and that is that I got my center of gravity where I had it when I had this just as a rubber powered free flight model. The little bit I got to watch it looks like the same flat glide, just carrying an extra 10 grams. You may have noticed that I got a lot of stuff out here. This idea of rubber powered model converted to radio control has been around for some time. I had plans on building a rubber powered radio control model as far back as probably about 1995. I framed the wing. This is Ed Lamb's Climber. It's a quite large rubber-powered free flight model. The thinking was build a model big enough to be able to handle the weight of the flight pack. Here is the balsa block I mentioned in the Beautiful Best video. Said I had another rubber powered model on the board. It's actually back on the board. So here's the block for the EdLam climber. Here's the kit, nose block, some hardware. My idea for this one, for a radio controlled rubber powered free flight model, is with this radio. This is an AM radio Bill Brunchy gave me, 2-channel. Here is the flight pack for it. So fairly small, lightweight AM receiver, 2 micro servos. These are high-tech HS 50s, and a little NiCad battery, flight battery. Interestingly enough, the flight pack for this AM radio setup weighs more than the all-up weight of this model with today's technology. .46, blinking 45, 46 grams. Let's take a little closer look at today's technology. This is the Spectrum 5-channel micro brick receiver. Has the 2 linear actuated servos built into it, and it has an onboard 5-amp brushless ESC if you wanted to set it up for an electric powered model. I have it mounted on a piece of 64th plywood, and I've drilled 4 holes through the pylon to give the epoxy purchase. The plugs are JST SH plugs. All these wires are smaller wires, lighter weight. Here is the 70 milliamp hour lithium ion battery. I just have it velcroed on the front here. This is the antenna for control rods. This is 25 thou carbon fiber rod connecting to the linear actuated servos. I have 20 thou music wire. This is a Z-bend for adjusting the neutral position. The wire is simply super glued to the carbon fiber rod with a bit of heat shrink tubing on it, and then soak that with CA. Moving to the back of the plane, take a look at how I set up the control surfaces. I have 2 pieces of heat shrink tubing super glued to the carbon fiber tail boom for guides and to add stiffness to the control rods. These are balsa wood control horns. After I cut them out, I soaked them with CA to strengthen them and also to harden them as far as the wear point on the 20 thou music wire going through here. These 2 pieces of music wire are attached the same way as up front. I cut out all the control surfaces on the mold lines that were in there. So I have 2 separate elevator halves. For that, I could flex this down enough to where I pushed a piece of the 25 thou carbon fiber rod through the foam. It goes about a 1/4 inch pass on either side. And I've super glued this balsa wood control horn to the carbon fiber rod with a small Teflon washer on either side. This control horn is epoxied in, and I have 2 pieces of Scotch tape on this side. On this side, I cut a 45 on either side of the hinge line, and I have 2 pieces of Scotch tape on that side. I've added a piece of white duct tape to strengthen this area where the carbon fiber rod goes through, top and bottom. I cut slots in the bottom of the elevator halves, put a small amount of epoxy in there to attach them to that carbon fiber rod. I also added a small piece of that duct tape for wear on the front platform here. I don't have any Z-bends. I'm simply using the spring tension, the carbon fiber rod coming through this last guide. Holds it in. Same thing where the control rod's attached to the servos. I do have a slight dog leg so that wire clears the servo motor, but spring tension from the control rod is holding them in. That way I can remove the control rods. I can still disassemble the plane. Right here on the tail boom, I have a small piece of heat shrink tubing super glued right here. That way when I seat that, my neutral position repeats on my control surfaces. There's a close-up look at the new technology that's out there. I had no idea that they were making RC components this small, from lithium-ion batteries that small and lightweight to a unit with the linear servos mounted right on the board, ESC on board if you wanted to run electric. That compact and small and lightweight, I simply have that mounted with double-sided tape. There's a look at the material and some tips and ideas on how to keep everything light for hooking up RC equipment this small. The last piece to this is how do you charge batteries that capacity. There's the charger. Has the JST SH plug, micro USB plug, plug it into any laptop to charge it. The key to this is it only charges at 100 milliamps. So I'll include screenshots of all these components and where I got them from. With this RC conversion, I've retained the ability to break the model down, mostly because I didn't use Z-bends on the control rods. I have sanded about a 32nd of an inch off the bottom of the tube in the front, giving me some down thrust. And I've also did the same for right thrust. So I'm committing to a right climb, left glide flight pattern. I've made up a motor from some tan Super Sport rubber, lubricated it, broken in. This is from a nice fresh batch of FAI rubber, August 1, 2021. And I have one more tidbit of information that I'm really excited to share with you. I've got a way to make my blades spring-loaded so they fold against the fuselage instead of flopping around. It's not hard to make. I made 2 identical springs from 10 thousandths music wire. The leg with the hook on it is 3/4 of an inch long. The leg with a 90-degree bend is 3/8 of an inch long. The throat of the hook is 3/16 of an inch. The 90-degree bend is 3/32 of an inch. For the spring action, as far as how I wrap this, I clamped a 1/16 of an inch drill bit hanging off the side of my bench, and from this hook side I wrapped it 1 3/4 turns. This one up here is on top of this one, so 1 3/4 turns coming out 90 degrees from the side with the hook on it. So I'm working with a longer piece of wire. In other words, I don't cut these off until after I make this wrap, and then it's a matter of making this 90-degree bend here, cutting it off at the length I gave, and then making this hook at the distance here. All there is to the making of the spring. So here you can see where this loops over top. So I hold on to this end and wrap this. To install the springs, remove this plastic cap. Then put the spring on with the end with a 90-degree bend towards the nose cone. Now replace the cap. You should have that. Now take the end with the 3/16 hook, put that around the prop. Next, take the end with a 90-degree bend, put it up on the nose cone, and you need to drill a small hole right through the nose cone. I already have my hole drilled. I use a 16 thousandths diameter drill bit. If you don't have a small wire drill set, you could heat up a piece of this wire and make a hole through the nose cone. The location of the hole needs to be right in line like this. Can't be over here where this will hit the wire. The location this way is going to be where that 90-degree bend comes out to be. But you get the hole drilled. Simple matter of dropping that in the hole, and now your spring is installed. I have it figured out using this diameter wire and the 1 3/4 wraps for the spring action, where the prop just lightly holds against the side of the fuselage, but will stay out from centrifugal force when the motor's running. Once you make your prop so it's spring loaded like this, you have to commit to stretch winding with a winder. You can no longer hand wind because the prop won't stay open like that hand winding. I have the plane reassembled. Now I'm going to use a stuffing stick to insert the rubber motor. So this has a fork on it that I put the motor on. Like so. lets me insert the stuffing stick and then put the rear peg through the rubber motor. Push the stuffing stick far enough in where I can push the pin through the rubber. Now remove the stuffing stick. Okay, ready for prop demonstration. Blades fold nicely against the fuselage. Now I have the prop released. Beautiful. Perfect day, dead calm. Let's check this glide. Might have pushed that a bit too hard. Got our launch nose up a little bit. Let's try a little more gentle launch. Oh, same thing. Haha! Wow, that's beautiful. Here's the one problem if I wind it up and test it, is I'm going to be landing this out there somewhere. Not good.